Great, I see a lot of smiling faces here. So let's have the fun continue with talking about some performance stuff. So we'll be introducing some performance tuning patterns and best practices in today's session. My name is Xiaochen. I'm a product manager lead, and my team owns MongoDB Query and also MongoDB Server Performance. And today I also have my coworker Frank to co-speak with me. Frank, do you want to introduce yourself?
Hello, everyone. My name is Frank Stein. I'm also a product manager. I'm responsible for MongoDB observability.
Great, thank you, Frank. So before we start our talk, we want to learn a little about you. So please raise your hand if you are a developer, application developers. Great. What about database administrators, DBAs, operation? Great, a few of you. Architect, application architect, data architect. Okay, I see a few hands. Managers, CIO, CTO, CXO. And did I miss anyone? Any friends from media? Any friends from okay. It feels like we have a really good mix of different job roles here today, and we'll make sure that our talk will suit all your needs, and make sure like every one of you will leave today's talk with some new learnings which you can apply to your daily performance tuning job and also performance management job. So in this talk, we'll have 12 tried and also tested patterns for application and the database performance tunings. So we did this talk 2 years ago at MongoDB World, that's still the World, and it was a 4 hours workshop, and we ran out of time. So today we only have 45 minutes. To avoid us only scratching the surface, what we will do is that we will have a quick introduction of each of the patterns, and we will go deeper into 3 patterns. And we pick 2 of those patterns for you to go with more details, and we'll get you to vote for another one. And during today's talk, we're also going to demonstrate some of the exciting new features which will coming soon in MongoDB AO or MongoDB Atlas. We'll leave some time at the end of the session to answer your questions, but if we don't have enough time to answer all of them, Frank and I will be here, around here after the session. If you have any question, feel free to come up to us, and we're happy to follow up on those questions. So let's get started. So all the 12 patterns today are organized in a 4-step thinking process. The first step is about context. So it's about the circumstances where the problem is. And the second one is the problem. So basically, what is the problem you're trying to solve? And the next one is the force, which is the contradictory conditions. In other words, what do you need to compromise, and what decision you need to make to balance between different factors? And the last one is the solution. Basically, how do you solve the problem? Let's try this with a simple story here. Let's say I started a business doing online delivery for organic prepared meals. I know there are a lot of them out there, so I'm not sure if my business is going to be successful or not. So in the beginning, I don't know what's the business going to look like, so I need to create a small MVP project to support my delivery service. And then I'm lucky, in this situation, my food is everyone likes it, and get vibe on the social media all over the place, and suddenly overnight it's becoming a super successful business. And also at the same time, it's bringing the problem, which is I have to scale my application and my database. And the forces here is that I have to spend time to do performance tunings to make sure that my database can serve the needs. At the same time, as a business owner, I don't have that time. I have to do other stuff to support my growing business. So if that's the problem you're facing today, you're at the right place. So today we'll be showing you the performance tuning patterns and the best practices which you can use in your day-to-day job to help you to tune database performance more efficiently and save your time. So the 12 patterns we'll talk about today will fall into 4 different categories. The first category is the big picture, followed by query and indexes, sharding and scaling, and the last one is put it together. So there are 3 patterns in the first category. So to begin any performance tuning task, you should start with understanding the requirement. So that can, to have a smart performance requirement, which is specific, measurable, achievable, relevant, and time-bound, will help you to avoid to run this as an endless task or shooting a moving target. So MongoDB, in general, database system is a very complicated system, have so many factors and so many tunable arguments, and they are all related to each other. Without knowing the whole system, it can lead to like a lot of surprising results when you're tuning your database performance, and it's often the case, it's like surprising in a bad way. So syncing system is also very important to be able to tune your database performance and gain optimal results. So once you know your requirements and you know the system, you can start to hunt bottlenecks, your performance bottlenecks. There are a lot of potential performance bottlenecks regardless if you're running your database either on-premise or in Atlas. So iterating through all those bottlenecks will help you to come up with a strategy, and also you can use all the performance tuning tools we have provided to do that, and Frank later is going to show you some demos about how to use our performance advisor in Atlas to help you to do this more efficiently. In the next category, query and indexes, we have 4 patterns. The first one is about designing schema. And there's like a very common misconception that MongoDB is like a no schema database. So that's not necessarily true. MongoDB supports flexible schema. It doesn't mean that you don't need schema for your data model. Actually, if you don't have a good schema design for your database, then you will not be able to get optimal query performance, especially when you have more and more data in your database. Once you have the data schema designed, then you have to start to think about creating indexes. I believe most of you, maybe all of you know that index will help you to optimize your database performance, query performance, but at the same time, it doesn't come up with, it doesn't come for free. Index is also going to use more resources and make some other operations run slower. So in this pattern, we're going to talk about how do you make a good balance here when you create index in your database. And once you become an index expert, you can start to think about some deeper stuff. For example, how to use a compound index to optimize some complicated query performance in advance. And the next pattern is quite straightforward. Use bulk writes when it's possible. But also it's not that simple because you cannot just use bulk write in all the scenarios. So here we're going to tell you like when you should consider use bulk writes. And in some other scenarios, you cannot. You should use as some other options. And the next category has 5 patterns in there. The first one is about how do you manage MongoDB connections and also the connection pools when you're using MongoDB drivers or other OEM tools. And because each of the connection you have with the connections and the connection pools, you have to make the trade-off between building a code connection which can increase your query latency, and also too many connections going to consume too much resources from your database. And when you start your business and while your business is growing, you always need to scale your database. So in most of the cases, we'll start from scaling up, but at a certain stage, scaling up will not be efficient enough. So we'll start to think about scale out. So in the next 3 patterns, we will be talking about the scaling strategies, including scale up and also scaling out using the sharding features we provided in MongoDB. So first, we can talk about how to select a good shard key to make sure you can have efficient queries and also balance your data evenly across all the shards. And then we can talk about when your database grows, how can you efficiently balance your data and make sure that you can keep getting optimal query performance. And the last one is about like the pre-production checklist. So basically, when you're rolling out any performance tuning results, or you're deploying a new database, or you're upgrading to a new version of MongoDB, what do you need to do before you do that to avoid any surprise results from your production workloads? So this is about the 12 patterns we have. And so Frank and I, we're going to talk about the hunt bottleneck and how do we do index. So if you can scan the QR code there, and you get to vote another one we're going to talk about today among the other 10 of them. So here's a bigger one, and if your camera doesn't work, there's also a link on the bottom of this page, and I will give everyone like about 30 seconds to vote, and then we're going to review the results. All right, 5 more seconds. Anybody need more time? Okay, great. Frank, so which is our winner today?
Looks like our #1 winner is understand
Sorry,
the
our mic
requirements.
I cannot hear you.
It's understand the requirements, #1.
Okay, we need one volunteer to make sure like what Frank said is correct.
Is that right?
Yeah.
Sorry. This one? Design schema. Oh. No. Design schema, right?
Yeah,
Design schema.
Is it verified?
#4.
Number 4, okay. So in addition to those two, we're gonna, those two hunt the bottleneck and the index, we're gonna talk about number 4. I remember it's design schemas, right? Perfect. So let's get it moving. So does anyone remember what was the #1 pattern on the list? Requirement, right. Yeah, I saw people say requirement. So before you do any index stuff, or even before you start writing any queries, you need to understand your requirement from your application. Do you need to run like a certain queries super fast? Or do you need to run like some queries from multiple clients with very high throughput? Like what about write? Like how often do you need to write your data into database, and how often do you need to do update and delete and perform those operations? So all those will set up a really good context and also help you to understand the circumstances and set up the right goal for your index tunings. So the problem here is like everybody knows that index will help you to accelerate query performance, but at the same time, they will also consume more resources from your database, like including CPU, I/O, your storage, and also the cache space. For example, if you add an additional index and load that index into cache, it will leave less cache space for other indexes and the documents. So that could lead some of the queries have to fetch data or fetch index from the disk. So that will introduce more I/O. And in most of the cases, that leads to slower queries because fetching from disk is way much slower than reading the data directly from the cache. And in the meanwhile, adding more index will also impact your write performance. So in MongoDB, there's some statistical data shows us like adding every additional index will have about between 5 to 75% impact on your write performance. I know a lot of people will be like, whoa, that's huge. But in fact, for other type of databases, including relational databases or key value stores, the impact is even higher. Like for example, in some of the relational database tuning guides, it will tell you that each index will use as much like 3 times resources as the original write performance, write operations. So now we can see what's the forces here. I'll say what is the contradictory condition here. On one hand, each of the index will use more resources. I'm gonna make my write performance slower. On the other hand, I need index to help me to improve the query performance. So in a lot of cases, especially for those simple queries, it's very easy to identify what index to use. But in some of the cases, especially when you have a different type of queries to run in your database, and also when you have more complicated queries, it's often very hard, very difficult to identify what it is optimal index design for your database. So there's not a single golden rule to help you to create index for all your databases. So the best way to do it is to try it out. So you can use the explain command from the query to examine which index has been used for your query. And also the explain output will also tell you how efficient this query plan is. You can see it from like how many documents it scans and how many fetches it does. And then you can try to create different indexes to improve the query performance. And in your test clusters, you can always drop the index and see what's going on. And you can check the log to find out those slow running queries after you drop the index and try to add different index to improve those queries. And if you're running your test cluster in Atlas, you can also hide the index instead of dropping it, so you will save the time from recreating it if later you want to bring it back. And in Atlas, we also have the performance advisor to help you to monitor your index usage and also making some recommendations on what index you need to create to help you to improve your database performance. And later, Frank is going to show a demo about how to use those features in Atlas Performance Advisor. And once you get to this like a more comprehensive stage, you can start to think about use compound index to improve performance of some of the common but complicated queries. So today, if you have a query which is not using the expected index you want it to use, and you can use a query hint to tell the query engine, say, hey, just use index A, don't be smart. The problem is that the query hint today is not persisted, which means every time when your instance restarts, you have to reset the query hint. So in MongoDB 8.0, we introduced a new feature called persisted query settings, which allows you to apply query settings, including index hints, which is persisted in the database, that means it can survive restart, upgrade, and other types of maintenance events. So I'm going to show you a quick demo about how can you use persist query settings to apply query hint, index hint to your queries. So let's assume like I'm a tax collector working in the Treasure Island. I'm trying to do a survey to people who's paying 50 to 500 gold coins as tax in 2023. And I have to form a special crew to survey the pirates, which is also living on the island because they're kind of dangerous. And to know who are those pirates and how many of them are out there, I need to query my text database and get some idea from there. So I'm going to do this through a Python notebook. And I'm going to specify my connection string, the text database name, which is just text, and also the collection name is 2023. And then I'm going to create some help functions for my demo. So the first function will help me to remove all the query settings from my cluster, and the second one will print out the explain output in a way like we can easily read it during this demo. I'm going to reset my collection to make my demo real. Like I'm going to remove all the query settings, drop all the indexes, and also delete all my data. And you can see now I have no query settings, and I have only the underscore ID index, and I also have no data in this collection. So after this, let me insert some data into my database first. So first of all, I assume like most of the pirates, they don't pay tax. Or they pay a little bit tax because they have other business. So I'm going to insert 1,000 pirates into this database, and they're paying 0 to 100 coins as tax in the last year. And I also assume all the ordinary people, they are good people, they're paying tax. So I'm going to insert 10,000 of them into the database who's paying taxes between 90 to 1,000 coins. Because their occupation doesn't really matter for this demo, we'll just call them ordinary people. To make this more real, let's also assume there are some good pirates living on this island. They're making a lot of money, and they're also paying a lot of tax. So I'm going to insert another 10 pirates into this database who's paying tax between 800 and 2,000 coins. So I'm going to run this cell and insert data into the database. So after the data is inserted, I will start to create index. So in this situation, it's very simple schema. So I will create one index per field, one on tax, another one on occupation. So now I can start run my query, which is filtered by occupation equals pirates, and the text between 50 and 500. And I will run it with the explain command, so it will tell me what query plan and what indexes this query is using. So let me run it now. And raise your hand if you ever used explain command and you know how to interpret explain output. Okay, I see about like 20% of you. I will recommend you to learn about it because it's a very powerful tool to tune your query performance. So in this case, you can see the first step the query does is do an index scan on the text index, and then do a filtering on the occupation. And okay, it does work, but what is the problem here? So the problem is like, the question here is this the most efficient way to run this query? So the explain output can tell me a little bit more about it. So you can see this query actually exempt 5,068 documents. And if you know the island or you know the database well, you'd be like, we don't have that many parrots on this island. Why do I need to examine that many documents? Can I do this better? What if instead of scanning the text index, let me scan the index on the occupation field? So to tell the query engine to do that, you apply a query setting to your database. So you apply it to the text database, the 2023 collection with the query, and then you tell the engine to say, I only allow you to use the index on occupation. So after you run this command, you will have this query setting persisted in your database. Remember, it will survive all the upgrade and restart events, and it will generate a query shape hash, which later you can use to maintain all your query settings. So now let's run this same query, exact same query again. And now you see in this time, instead of scanning the text index, the query engine is using the occupation index to do the index scan and then filter on the text. So the result is that it only scans 1,010 documents instead of more than 5,000 documents. So the query runs way more efficient. And when you have a large data set, you will see like even bigger difference. So the query settings is also applied to a query shape, where we ignore all the literals. So like, let's say this similar query, but the difference is like the range of the text is from between 50 to 600. You can see it's also being forced to use occupation index. So to learn more details about how query shape look like, you can use this new aggregation stage called query settings, and with the show debug query shape options. So you can learn about the query shapes and know exactly what query settings you have been made. At the same time, this also means that it could be a little bit dangerous for you to just randomly set query settings, because it's not only impacting a single query, it's impacting all the queries in the same query shape. So when you do this, we recommend you to well test it before you deploy it to the production environment. So with this, I will hand it to Frank, and he will he will talk about how do we hunt bottlenecks in MongoDB database.
Awesome. Thank you so much, Xiaochen. Hello, everyone. My name is Frank, and I'm very excited to talk to you today about some of the new improvements we've made to MongoDB Atlas and how you can use them to effectively hunt and troubleshoot bottlenecks in your database application. So let me first set the stage. Imagine, if you would, just a beautiful night sky filled with countless stars and celestial objects. When you look at it with your naked eye, it's absolutely breathtaking. But if I were to try and find just one specific star without any contextual information, it might take me all night. And even then, I'd have a pretty low degree of confidence. However, if you were to give me a few constellations already kind of highlighted, let's say I'm looking for the Regulus star, and you were to tell me that the Regulus star is the brightest star in the Leo constellation, well, then I might be able to find it in just a span of minutes, and I'd have a pretty high degree of confidence. So this pattern of using contextual information and kind of scoping down the problem works just as well for diagnosing problems with our database. And oftentimes, diagnosing a database problem can feel like this. There are so many different hypotheses, so many different permutations for why something may be going wrong. It could be because my cluster tier is under provision, that I'm resource constrained. Or it could be because I have a non-optimal data model. Or maybe I'm running a number of inefficient queries and I'm missing indexes. There's so many different reasons why something may be going wrong. And by using the right tools that we provide in Atlas and scoping down the problem, we're able to uncover insights and anomalies about our database that might have otherwise gone unnoticed. So let's take a specific problem, and we'll work through this together. So to set some context, let's say I run an e-commerce store, and my application consists of a number of different microservices. I have inventory management, I have product search, recommendation, I have transaction management, payment processing, etc. All of these different microservices work together to provide a service for my customers. However, just this week, my storefront went viral, and I'm seeing much more traffic on my website. And this increased traffic is resulting in increased latency. And customers have now started reporting that they're seeing increased wait times with my application, with my website, and they're unhappy with these increased wait times. So what are some of the challenges that I may have in identifying what's wrong with my application? Well, first off, with so many different microservices, it can be difficult to find what the bottleneck is. It may not be immediately obvious to me, and trying to find the exact source of the problem may be time-consuming. And secondly, bottlenecks are time-sensitive. What starts off as just a service degradation today may very quickly devolve into a full-on outage. And so this is definitely something I want to get ahead of, especially for a small business like myself. Okay, so in order to solve this problem, we're going to follow a few steps here. The first thing is we're going to gather data, and we're going to look at some of the tools that we have available in MongoDB Atlas and how we'll use that information to work through our iterative process. So let's put this into practice. So we know the problem is that our application is slow. Customers are reporting that our website is slow. And there, as we talked about earlier, there are a number of different reasons for why this might be. Could be because inefficient queries, or it could be because my database is resource constrained. We'll focus on quantity first. We'll just produce a number of different hypotheses for these, and then we'll use our data and we'll use our contextual knowledge, and we'll prioritize the ones and iteratively work through these. So let's take a look at some of the tools we have in Atlas and see how this works. So the first place that I'll start is I want to take a look at my metrics charts. My metrics charts will help me provide a high-level context for where the problem might be. Here I have a few metrics already picked out. I have the number of operations that are running, as well as operation execution time. Overall, I'm not seeing anything that's a significant concern here. And obviously, there's a lot more I could do here to further contextualize the problem. I could look at additional metrics. I could expand the look-back period and gain further contextual knowledge that way. But for the purpose of time, I'm going to focus on a new tool that we have available here today called our Query Insights tab. So if we go back to our night sky analogy, just like we were breaking down the vast night sky into different constellations, with our Query Insights tab, we're breaking down our host-level metrics into collection-level metrics. And if we look here, we can see we're seeing our collection-level latency metrics on an individual collection basis. And right off the bat, I can see that the latency on my transactions collection is significantly higher than my other collections. And let's expand our look-back period, and we can see that this problem started around 24 hours ago, which corresponds more or less to when customers started reporting the issue. And so just like that, we're able to gain additional context about where the problem might be, and we know that something may be happening on my transactions collection that warrants additional troubleshooting. Now, let's take this a step further and further validate our hypothesis. So again, I can continue to use Atlas to further prove or disprove my theory. So now I know there's something wrong potentially with my transactions collection. let's see what the root cause of it may be. And so again, coming back to our night sky analogy, we're now looking at the individual star within our constellation. So we want to see what operations are causing that increased latency on my transactions collection. And here on our query profiler, we can see individual slow operations that are running on my database. I can hover and click on each of these data points, and I can see additional metadata about these slow operations, including what namespace it's running on, what host it's running on. I can click on additional information, and it'll show me the exact command that's being run, along with other metadata about the client making the request, and information such as whether or not this is a collection scan. And here I can see that this query on my transactions collection is indeed a collection scan. And it looks like there's quite a few executions of this query as well. So if I think about my application workflow here for just a bit, I'm running an e-commerce store. My e-commerce workflow, when users submit an order, I show them information about their recent order. I'm showing them things like their order ID, maybe the cost summary, maybe recent order history, everything like that. If I'm having more and more customers place orders on my website, that's creating more and more documents in my transactions collection. And if all of these queries are collection scans, then that could be a very good reason for why I'm seeing increased latency on my website. So now we've validated our hypotheses. We know that this is because of a collection scan and an unoptimized query. It's time to make a change. And we know that the change that we have to make is we have to index our collection scan. But how do we know what field to create the index on? This is where our Atlas Performance Advisor comes into play. So Atlas Performance Advisor scans your slow query logs, and it provides you recommendations on how to optimize your database performance. If we look here, we have a number of recommendations, including an index creation recommendation. If we click into this, we'll see that we do indeed have a recommendation on our transactions collection, and it's on our customer ID field. So this would allow us to much more efficiently query for recent transactions and speed up the time to retrieve documents. So now that we've made our change, the next step is to observe the effect. We'll want to go back to our metrics charts, and we'll want to verify that this had the intended change or the intended result. And if this does satisfy the requirement, then that's awesome, we're done. But if not, we'll continue to iterate through our hypotheses, and we'll continue to iterate until our requirements are met. So let's go back to our Query Insights tab here, and let's take a look at how that index has impacted our performance on our transactions collection. And right off the bat, I can see an immediate decrease in the latency on my transactions collection. It looks like things have significantly decreased, and I'll keep an eye on it, but I think things have stabilized. So now I can go back to my customers, and I can tell them that I've rolled out a fix, and that I'm continually invested in customer experience and making sure that they can effectively use my website. So in conclusion, you can see there's a number of steps that I took here. I used the tools available to me out of the box with MongoDB Atlas. And I used that information to contextualize the problem and work through my iterative process. And ultimately, this allows me to spend more time doing the things I love, like stargazing. So with that, I'd like to pass it back to Xiaochen, and he's going to take us through our last topic.
Okay. Thank you, Frank. Our friend in the backstage, can you help us to jump to slide 118 so we can talk about the patterns you guys voted earlier, which is design schemas. Please give our friend a few seconds to find the slide 118. Perfect. So design schemas. One of the biggest benefits you can get from MongoDB compared to traditional relational databases is that you get flexible schema. So you don't have to start to think about schema design from day one when you're building your application. So that gives you more options, like when are you going to think about the schema design. So you can think about schema design when you start or in the early stage of your project, which will give you the benefit, like in the future, it might be easier for you to scale your application and scale your database. But also you also have the flexibility to do that later in your project when there's new use cases coming in, new document type coming in, or new feature changes. You feel like the performance of the database dropped, and then you can think about how can you optimize the data schema to improve the database performance. So first of all, we already talked about it. MongoDB is not a no schema database. We provide flexible schema, but you still need to design the schema tailored to your query shapes. And also new use cases, new document shapes will often make your database and your queries run slow. And that is when you start to think about how do you optimize the data schema to help you to gain better performance. So what are the forces here? First of all, flexible schema is great. That means like you can model your data naturally with arrays, with subdocuments, and with key value pairs. It can also be tables. And you can modify your schema without any database downtime. Like if any of you use the relational database, you will know how difficult it's going to be to add a new column to a table. And at the same time, the natural model also means simplicity. Like compared to relational database, typically MongoDB application has 8 to 10 times less collections compared to the tables. But at the same time, like optimizing your database performance sometimes means like introducing higher cost. For example, there's optimization strategies that you can duplicate your data, which also duplicate the storage cost. And in some cases, you can optimize your query performance by optimizing the memory size or optimizing the CPU usage. So what are the solutions here? First of all, you should always think about it from your query instead of what data you have. So basically, what query application will be run, what are the most important queries to your application, and that can lead to more efficient queries for longer term, instead of suit your queries to your data shape. And one of the decisions you have to make all the times when you're using MongoDB is like, when do you need embedded subdocuments, and when do you store them in different collections, and when you need to link those documents, you have to do lookups. So you need to make trade-offs in those situations. And the next thing about it is like you always review your data model and size your data to fit as much of data possible into your memory. So look at through a quick example here. So let's say you are building a website selling books, and you have this books document, and also for each of the books, you allow your customer to put comments in there. So there are two ways to store them. The first way is to do embedding. So basically, you have an array in your books document to store all the comments. And the second way to do it is to referencing. So basically, you have one collection store all your books, and another collection store all your reviews. So there are like pros and cons in each of the design. So for the first design, you'll get faster info. You'll get all the reviews really fast. Every time when you get the books document, you get all the reviews. But think about if you have your business boosted and you have like 1,000 reviews for your book. Every time when you're fetching the document, you're fetching a lot of information you probably don't need. And for the second one, you won't get any of the comments when you fetch the book information, but they will help you to query the book information very fast and show it on the website in no time. And there's also like a trade-off you can make in between. For example, you can only store the last 5 to 10 comments in the book, embedded in the book document, and store the rest in a separate collection. So when people go to your application, they will automatically see the first 5 or 10 comments, and when they load more, you will query the other collection to get other feedbacks. So another thing you can do is use the tools, the Compass tools, to understand your schema better by visualize it. So you can always examine like some examples of your data and also your data distributions, And for example, you can see how many different values you have in a certain field. And if it's an array field, what's the distribution of the length of the array. And this feature is also available in both Atlas and also for your self-management environment. And another exercise you may want to do when you're designing your schema is the memory sizing. So you have to define your working set of data. So basically, like, what data do you want them to always to be in your cache or say in the memory, so you can access those data without fetching them from disk. So let's look at it through a quick example here. Let's say you're designing a mobile game. You have some system data, it's 16 gig, you want all of them in memory. You have indexes, you want all of them in memory. And you have player data, and you want like a quarter of them in memory. So you add everything up, you will need about like 172 gig memory. And remember, the storage engine dedicates 50% of the physical memory to be in the cache. So you will need 344 gigabytes in the memory, of memory. So this exercise is very important for on-premise. And in Atlas, you can also use our auto-scaling features to achieve this, to avoid doing this, and you can adjust it in real time. Please, can we go back to the slide 50, please? So I have half a minute left. I'm sorry we don't have enough time to answer your questions, but as I mentioned, Frank and I will be on side of the stage after this session. You can come to us if you have any questions. And I hope in today's session you learned some very useful patterns and best practice to your database performance. And unfortunately, we don't have time to talk about all the patterns. And if you scan the QR code here, we'll have a post in LinkedIn, which you can find all the future readings and the articles, blog posts we had, and you can learn about it. And if you have any questions, we'll be here. And thank you again coming to today's session, and enjoy the rest of your .local event. Thank you.